What's up, dudes? Happy Tuesday. It's March 30th. I wanted to make a video to summarize the video that you guys have for your assignment today, Evidence of Plate Tectonics. This video should not replace the video online. Okay, I understand the video and the assignment is a little bit dense. It's a little bit tough at points, but I want you to watch that, and then with that and this, you'll have a much better idea of what you're talking about. Okay, so first thing, if we're looking at the globe, okay, we're looking at a map of the world, all right? As a small child, you could look at that and be like, if you cut all the pieces out together and gave it to a kid and we're like, put this puzzle together, right? They might not get it perfectly, but like the kid is going to start fitting pieces together. And as adults and as, young adults, you guys can look at that and you can be like, man, you're right. Like some of those pieces do look like they kind of fit together, right? Like Africa and South America, like they've got like those cutouts that fit perfectly. Like South America kind of pops out, Africa kind of pops in, boom. Those pieces look like they fit perfectly together, right? And not even knowing anything about the plates, you can just look at that and say, okay, yeah, like the land looks like it fits together. But now, knowing as scientists and being able to map the like lithosphere and being able to see the actual plates and where they are, like we know there's a plate around Africa, there's a plate around South America. Like those things were moving or are moving and could have potentially been together, right? Obviously looking at the map and saying, oh yeah, like it looks like they fit together, that's not enough to say like, oh yeah, plate tectonics is real, right? Alfred Wegener, he was the scientist that said like, I think this might have been a real thing, like check this out, and they like laughed him off the science boards, right? Like he wasn't like around the cool scientists anymore because they thought he was crazy. But he didn't know the things we know now. But that's one big, like really easy piece of evidence. It's just simply looking at a map. You can see these things look like they fit together. Okay. Let me take a peek. Make sure that really answered everything for question 1. Yes, I believe so. All right, sweet. Taking a look at the Mid-Atlantic mountain range, okay, this is just a big mountain range in the middle of the Atlantic Ocean. And in the video, he really talks about this for like the last 10 minutes of the video. It goes back towards this a lot. Like when he's talking about the magnetic rocks and stuff, this really does still relate to that mountain range. But the big thing is the fact that there's just a giant mountain range down there. It tells us something is happening, right? Because that mountain range is changing. We can map that. We can see that it's growing. We can see, when new rock are being pushed up, when older rock are being pushed out of the ground, whatever, right? We can see that, and we know, even if we don't know what it means, we can look at that. We can look at the data of, oh yes, this mountain is growing, and know something is happening, okay? And again, saying, okay, well, they look like they fit together, and we know that because of that mountain range, something is happening. You're right. Like, those two pieces of evidence do not, make this a foolproof argument, right? But when we're putting all these pieces of evidence together, it starts to build it up a little bit more. Another thing that he talks about, and it's kind of just glossed over in this video, I actually don't even know if he mentions it, but another thing that's very interesting when it comes to thinking about how the continents look like they fit together is fossil records, right? If we can find fossils from millions of years ago of an animal that was a land animal that would have not been able to swim across an ocean, right? And we can find that fossil in South America, and we can find that fossil in Africa, that tells us that either these two species evolved completely independent from each other in their own continents exactly the same way, which doesn't tend to happen, or these chunks of land were touching, they were together, or they were at least close enough to where this animal could have made it across somehow, right? We have cases in history and through science where, like bugs and rodents and stuff will get caught up in driftwood, and they'll drift, long ways across oceans, bodies of water, and be able to reproduce and populate other areas. But say if we're talking about, like a giant, I don't know, like a prehistoric cow or something that's not going to be able to swim thousands of miles in the ocean, right? And we can find that thing in South America, we can find that thing in Africa, we can find it in parts of Europe. Like that tells us these things were connected. They were able to walk there. Okay, so that's another good piece of evidence. And to kind of step back into the video's evidence pieces is thinking more about the mountain range and those magnetic rocks that he's talking about. And before we can really get into the magnetic rocks, you need to understand that the magnetic field on Earth flips over time, right? And talking about why and how, that's like a whole nother science class, okay? For this, we just need to be able to understand and accept that the magnetic pole on the Earth does flip over time. And we're not talking about like it's going to flip tomorrow, like it could, but we're talking like over hundreds of thousands of years. It'll flip several times over the course of like a million years. Thinking about human existence, right? Like we've been here for like a blip in time. Like we're in the single thousands of years of like Homo anything species, right? Like Homo neanderthalis, Homo sapiens, Homo whatever, like Deandaris. I'm not the evolution expert, sorry. I'd have to do a little refresher on it. But all of the different humanoid species, like we're talking single thousands of years of existence on Earth, right? When we're talking about the Earth's pole, magnetic pole flipping a few times over a million years, right? Like that's way longer than humans have been in existence. Okay, so when we're thinking about that, like for you guys, we have to put that on like a huge time scale. Okay, so we're talking like a million years. We're gonna see like 3 or 4 flips. Okay, so think about that for a second. And when I say flips, what I mean is like if you've ever seen a compass, right? And you look at the compass, the needle points north. And if you don't know what I'm talking about, please let me know. Like just holler at me and I will show you guys a compass. I'll go find one somewhere. But it points north, right? I think you guys have them on like your iPhone apps. They have a compass app now. Okay, so that thing points north. You know, over that million years, that magnetic field, that point is going to change. So it'll actually point to the south, right? And then over thousands of years, it'll be back to the north and then back to the south, okay? So when new magma is coming out of the Earth, okay, it's liquid. And when we were in our states of matter unit, we learned that liquid is free to move, okay? It's not like gas where it's all over the place, but in its liquid state, it can kind of move around and take shape of its container. Outside properties can act on it, right? So a magnetic pole, any magnetic material in that rock is going to point towards that pole, okay? So let's say for this hundreds of thousands of years of this magma bubbling up and making new rock, those were all pointing towards the screen, okay? And then over 100,000 years, that magnetic pole has flipped, okay? Now when you go farther out, that older rock, they're going to see, I should have gone back in time, right? Because it would be older rock the farther out. That older rock is going to be the opposite direction. And then you go back 100,000 more years and it's back the opposite direction because the magnetic pieces were following that magnetic pole, trying to point whether it was at the top or whether it was at the bottom. So by being able to see that it's flipped, right, we can see that those rocks are different ages. And by being able to tell that these are different ages over time, we can see that they're moving over time. Okay, we're able to tell where those rocks were at certain periods of time. So when you look at each piece of evidence on its own, it's not great, right? But when you can look at it and say, well, it looks like a puzzle, now as scientists, we can look and actually see the plates and be like, well, those puzzle pieces are actually on pieces that can move. We can find the same fossils of plants and animals on all these different continents. There's mountain ranges in the ocean. There's mountain ranges on Earth that we know how they behave and what they do. And as well as this magnetic rock that tells us how old things are, we can kind of start to date and age where the continents on Earth were over time. And it's pretty wild. It's pretty crazy. Okay, so hopefully this video with your other video, you can kind of package that together and use that information to help you guys. Remember, I'm always here to help. I was pretty excited with how many decent grades I was able to give. I was pretty worried towards the end there with a lot of low grades, but a lot of you guys really kicked it into gear. I want to remind you guys that this quarter, I'm only going to be following that 2-week policy. So every 2 weeks, that's all the work that I'm looking at, right? So then once we're into week 3, I'm not going to look at week 1 of this quarter anymore, okay? And when we're in week 4, I'm not going to look at week 2 anymore. Okay, so you really need to stay on top of your work. I'm not going to be going back and checking everything. Okay, so make sure we're on top of it, and let's be ready to work. Let me know if you guys got any questions. I'm here to help. Love you guys. Hope it's all going good. See you later.